Hey everybody, we are in week 16. We're about 2/3 through our way of our geology unit. Next we'll have rocks and minerals, but we're going to take a little assessment on what we've done so far. So when you look in week 16 with the warm-ups, here we go. Today's warm-up, do this in the back inside cover of your science notebook. We'll talk about Skyward and Google Classroom in just a second. When you've got a graphic of any kind, maybe it's a map, maybe it's a chart, maybe it's a graph, always take a look at it to kind of get a grip on it before you start looking at questions, right? Even on a warm-up. So notice this is obviously South America. I could tell, plus it's labeled. They're labeling some of the different biomes that the people could live in, right, and the animals. But notice down the side, they're drawing my attention to the Andes Mountains. Okay, nowhere on here do I see plate boundaries, or anything like that, but I know that there's a long string of mountains that's probably going to be from tectonic activity. Okay, so first off, it asked me to name the two plates that create them. So I look at the Andes Mountains and I look on either side. All right, so I'm looking for plate names. So this is part of the South American plate. Remember that even includes out here in the water. You have various maps of the tectonic plates that you should know all their names at this point. So look back in classroom and find them and quiz yourself on them. Now, luckily, most of them are oceans or continent names already, but some of the major plates aren't those things, and so you need to know them all. Don't be, don't just look at this and assume it's the Pacific plate, all right, because the Pacific plate is huge, but this part right here, when I look on my stuff, is the Nazca plate. Remember, it's named after a people group. All right, so this is the Nazca plate, it's covered with water, and the South American plate. And question 2 asked me if they are each continental or oceanic. Well, the South American plate is continental, at least on this boundary side. On the east side of the plate, it's going to be oceanic, but they're worried about right here on this boundary. And then the Nazca plate, see the water, is oceanic. Okay, and then ask me what type of plate boundary. Okay, I don't see any arrows. Sorry. No, to tell me, but I know I have an oceanic and a continental, and they're forming mountains. And I can't tell by looking, but they're probably volcanic. So I know these two are going in a head-on collision, so those are going to be a convergent plate boundary based on the land feature they formed. Okay, this is part of how we figured out where the plate boundaries are, because the real Earth doesn't have red lines on it. Okay? So you need to be comfortable looking at lots of different plate boundary maps, and here's an example of one where they have been kind enough to put these pairs of arrows. So you should be able to identify the plates, because if I say, look at the boundary between the Eurasian plate and the North American plate. So you have to know where they are, and then look at the arrows. These arrows are moving away from each other. So I know that this is a divergent plate boundary. Okay, or other places when they're going on head-on collisions, like if I say find the Pacific plate and the North American plate, what's going on there? That's going to be convergent. Right, or we talked about the San Andreas Fault in California. Notice those two arrows are sliding past each other for a transform boundary. All right, so you should be able to find any of those locations, and especially if you're given arrows, determine what kind of plate boundary it is. Okay. If you click on this link right here, you're familiar with NASA, which is the space program. Well, the government has one for geology. It's the United States Geological Survey, so they monitor volcanoes and earthquakes and landslides and all the geology things. Okay, just as important. It's just you're not as familiar with them. Okay, so when you click on it, it'll take you here. And this is fun to play around with, because what you're looking at is obviously the United States, and you see this red line, that's that San Andreas Fault. Okay, that's a plate boundary line. Okay, but you see these little dots, and you see there's a key here. Okay, the size of the dot tells me how strong of an earthquake it was. So the bigger the dot, the stronger the earthquake. And then the color tells me how old it is. All right, well, this particular map that I'm looking at is just the past day, the last 24 hours. So everything on here is going to be red or orange, right? And even while you're looking at it, it may say map updated and a red dot pop up. Okay, so kind of look at where they are. These make sense along the lines, right? These other ones, there's still motion of the plates, because remember, this entire plate is moving. And some of these can be caused by like drilling, like fracking as well. Okay, but the plates are still moving. Remember, we've got the Volcanoes fault line going through San Antonio. It's just dormant, so it's not currently active. Okay, but there's other things going on, and like volcanoes up here that can erupt and shake the earth. Okay, so you've got your key here. And this is fine to see what you need to see, but sometimes it's better to look at it with some perspective. Okay, so here's the ocean one. You can see those major rivers and how they run together down the Mississippi. Right, look at the texture of the ocean floor. Right, so you talk about like the continental shelf. That's just what happens to be covered by water, but then there's the big drop off. So think like in Finding Nemo when the babies are by the drop off. You can look at it for terrain. You can definitely see the mountains better. Okay, street one, that's like looking at Google Maps. Not super fun. The satellite one is probably the most realistic looking, right? But for what we're doing, we kind of need to keep it simple. But once you get where you want to go, you can play around with these. Let me close that so it's easier to see. Right? Maybe I want to look at something different in the United States, or maybe I can't see Alaska and I want to see Alaska. So Alaska's been busy, right? And you see this plate boundary, right? Here's the Pacific plate. Right? So Alaska's had some going on. Or maybe I want to go out and look at the whole world. Okay, let me close this. Now be mindful that it kind of duplicates itself because it's taking a lap around the entire Earth. And right below where you see my face, that's the coordinates, the longitude and longitude, that you can find certain things. Ooh, look, a red one. Okay, and when I click on that one, notice over here, it tells me it's in Hawaii, and it gives me exactly what time. You're like, I don't know how to read that, Miss Melanie. This UTC is universal time. They don't have to worry about central and standard and mountain, right? And it gives me some of the details about it, exactly where it is, what its magnitude is, okay? But there are other ones that have happened in the last 24 hours that are bigger, because we tell by the circle. Okay, but this has just been in the past day. Maybe I want to see last week. Okay, so there's more to it than that. So I come up here and I can change. If I want to look at the last 7 days, notice how many more have popped up, right? Notice exactly where they're happening. There's very few in the middle of plates. Most of them are along these boundary lines. And that's how we figured out partially where they were before we had sonar and we had satellites. Okay, we were paying attention to where this action was. But even still, I can go a little bit more, and I don't think I can move my. Oh, I can't believe it. I'm moving my face. Okay, if I want to look, that's the big ones, right? But if I want to look at all of them, see how there's more dots? These are just smaller earthquakes. Okay, so notice it goes to the past month. When it says significant, these are the ones you'd probably hear about on the news, right? So you're like, okay, just a handful. But when I look at the 4.5 and up, boom, even more. Or if I look at the 2.5 and up, even more. Okay, and these are all that have happened within the past month. So this is fun to play around with. And you could go back when you find the one you want, look at it like this, look at it like this, etc. Okay, but you can see why we're having earthquakes and volcanoes. Remember, because when the volcanoes erupt, they quake the earth too. Okay, so you can play around with this is called the earthquake hazard map from USGS. Okay, but here's what went down in class today. Okay, in classroom there's a plate tectonics drag and drop. So you use the information we did with snack tectonics and the notes we took just to make sure we understand it. You need to double check if you have any missing work. Most kids either owe me nothing or owe me like 6 things. There's not a little middle ground. But double check Skyward in case I have a typo. Maybe it's supposed to be 100 and I typed a 10. Oops, I don't know unless you tell me. Check Google Classroom with your to-do list. Right? I may have sent something back to you to fix or finish and maybe sent comments. You need to read them. And just double check that all your ed puzzles are done. Okay. You want to go through your science notebook and remember my files on Classroom because all of the stuff behind your geology divider is what's on your test. Right? So density. You should understand how to calculate it and how it plays into geology, like with the layers of the earth and the oceanic and the continental crust. You should know all of the compositional layers and the mechanical layers. Remember, those are the fancy ones, right? And their properties, their characteristics. I'm not going to ask you anything crazy, like how thick is the continental crust? You just need to know that it's thicker than oceanic. So remember that this file won't be open on test day. So you need to make sure all this is in your science notebook. I'm not going to ask you anything like, we didn't write on temperatures. I'm not going to ask you the thickness of the core, just the general thickness and thinness of each one, or the general density of each one, or the overarching patterns of temperature and pressure. It increases as you go down. Okay, you've got your edible earth. Maybe you need to, for science, cut open another candy bar and compare it to the earth, because we hit modeling hard in geology. So you should be thinking, Mr. Casey, very, very good at this, picking out the strengths and the weaknesses. Okay. And there's some other candy bars that may be different than the ones you had. With continental drift, remember our major player is Alfred Wagner, early 1900s, and it was the idea that the continents were moving, but he didn't know how. So drift implies that they're kind of aimless, just going wherever they please, which we know now is a little different, right? So he had evidence, he didn't have the how, right? So you should have like 3 or 4 things of evidence here, like the fossils and the climate, the jigsaw puzzle pieces of the continent, right? You should go back and look at the continental drift drag and drop or the videos to fill this in. That's what we did in class. But his problem was he couldn't explain how they were moving. He didn't have a mechanism to explain how giant, huge, heavy tons of rock were moving across the earth. Right, so he's a little before his time. But later, when we had the invention of sonar and later satellites, and we can see the bottom of the ocean, they're like, oh, he was right. But that was the 1.0 version. The 2.0 version is the theory of plate tectonics, which is what we are talking about now, with all of this plate motion and boundaries. So you need to know 3 types of boundaries, right? The convergent. And with each of these, like if I say, what type of land feature could I find at a convergent oceanic boundary? You should be able to tell me a trench and volcanic island arc. Okay, so you've got the convergent, your divergent, and your transform. And you can go back to the videos where I explained all these. And then you probably need to add some to your Snack Tectonics sketches, because we're kind of in a hurry. So go back and make sure you've labeled what they actually were and what they were representing for all of your sketches. And feel free to, snack again for reinforcement to help you study. Okay. And notice I put some Quizlets up to help you as well. Okay. And then last on your list is the Google Earth Scavenger Hunt. Okay. This isn't due until after your test. Right, but this will help you with some of the land features, plus Google Earth is awesome. Right, but don't do this if you owe me 4 things. Right, this is for do this only after everything else is done and turned in, including missing work. This means you. Okay, but you're going to go to different places on the globe. Just follow the instructions. Right, I have Tuesday after school tutoring, which is today, if you're watching it today. Right, and then Miss Henning has it on Thursday morning. But the next time I see you, you will have your test over all that material. All right, so go through your notes, go back and rewatch the videos if you need to, go back and watch the ed puzzles, play the Quizlets to make sure you are competent with all of this geology material. Thanks.